Let's look at another example of Shell's method. Find the volume of the solid of revolution from rotating the area bounded by 4 minus x squared and y equals 0 about the line x equals 3. The y equals 4 minus x squared is the parabola, the y-intercept at 4, and the x-intercept at negative 2 and positive 2. Y equals 0 is the x-axis, and the line x equals 3 is the vertical line. Sketch the graph. By the shell method, we draw the bar or the slice parallel to the axis of revolution. In this case, is the line x equals 3. The position of the bar is x, where x between negative 2 and positive 2, and this is the interval of integration. To rotate this bar about the axis of revolution, we'll form the shell. The thickness of the shell, or the delta x, or dx, the height of the shell, or the bar, is the height of the function, or the function value. The height is 4 minus x squared. The radius is measured from the axis of revolution to the position of the bar. In this case, the measurement of the radius would be the right function, which is x equals 3, and the position of the bar, which is at x. Set up the volume of revolution. V equals integral from negative 2 to positive 2. 2 times pi times the radius, which is 3 minus x, times the height, which is 4 minus x squared, times the thickness, or dx, or the width. Next, simplify the integrand and bring 2 pi outside of the definite interval. 3 times 4 and 3 times negative x squared, 4 times x times x squared, x to the third. Find the antiderivative. 12x minus x to the third minus 2x to the second plus x to the fourth over 4. Evaluate from negative 2 to positive 2. Replace the x with the upper limit. And subtracted by the value from substituting the lower limit. We will get 64 pi as a result. Let's take a look at another example of the Shell's method. The area bounded by y equals 4 minus x, which is the line with the slope negative 1, the intercept at 4. The line y equals 1, or the horizontal line, the x equals 0, or the y-axis, about the x-axis. The region bounded by these two graphs has intersection point at the order pair 0, 1, 0, 4, and 1, 3, and 3, 1, sorry. 0, 1 right here. The axis of revolution is the x-axis. By the shell method, we draw the slice or the bar parallel to the axis of revolution. So this is the y position, where the thickness or the width is delta y, and the y value will be between the value 1 and 4. Therefore, the interval of integration would be from positive 1 to positive 4. The width or the thickness is delta y or dy. The radius of this shell is measured from the axis of revolution to the position of the bar, which is y, and the height of the bar, since this is the function with respect to y, the right function, which is the line y equals 4 minus x, will be rewritten as x equals 4 minus y. And the left function is the line x equals 0. So the height is computed from the right function minus the left function of 4 minus y minus 0, or just 4 minus y. Now we put together as a definite integral representing the volume of solid of revolution. So V equals the integral from positive 1 to positive 4 of 2 pi times the radius, which is y, times the height, which is 4 minus y, times the width, which is dy. Simplify the integrand. We have 4y minus y squared. And then find the antiderivative to get 2y squared minus y to the third over 3 from 1 to 4. Plug the value in upper limit 4 subtracted by the lower limit 1. Plug the 1 into the expression. 2 times 1 squared minus 1 to the third over 3. Simplify the numbers and it will give us 18 pi.